The first alert was noisy but familiar. Database connection errors above threshold. Then another. API error rate above 25%. Slack started filling up. Seeing login failures. Checkout is timing out. Auth service throwing DB errors. I opened Grafana. Request volume was steady. CPU looked normal. Pods were not crashing. But database errors were climbing fast. Connection refused, authentication failed. And it wasn't just one service. It was everything that touched the database. At that point, it was clear. This was not a single service issue. Something central had broken. We were running on AWS. Primary region in US East 1, EKS cluster with about 70 microservices. Traffic averaged around 2.5K requests per second. Core data sat in RDS PostgreSQL with multi-AZ enabled. Applications connected through a shared database user per service. Credentials were managed in AWS Secrets Manager. Secrets were synced into Kubernetes using external secrets. Each service mounted its DB credentials as environment variables. We had recently enabled automatic secret rotation. Lambda handled rotation every 24 hours. CI/CD was GitHub Actions and Argo CD. Monitoring stack was Prometheus, Grafana, and Loki. From an architecture standpoint, everything was designed to be secure and automated, especially secrets. That part mattered. But users could not log in. Payments were failing. APIs were returning 500 errors. From the front end, it looked like the system was down. But inside the cluster, things were running. Pods were healthy. No restarts, no CPU spikes. Even database metrics looked fine. RDS was up, connections were within limits, no failover events. But authentication errors were everywhere. That contradiction slowed us down. The database was alive, but nobody could talk to it. First thought was network, maybe a security group change. We checked inbound rules. No changes. Connectivity tests worked. So network was fine. Next thought was database overload, but metrics showed normal usage. No spikes in CPU or connections. Then we looked at logs. Application logs were clear. Password authentication failed for user. That pointed directly at credentials. We checked Secrets Manager. The database secret had a recent version. Rotation had occurred about 10 minutes before the incident. That timing matched perfectly. Now the question was simple. Did rotation break something? We checked the secret value. It had a new password. We tried connecting manually using that password. It worked, so the database had accepted the new credentials. Then why were applications failing? We checked one service, printed its environment variables. It still had the old password. Now things started to connect. Secrets Manager had rotated the password. Database accepted the new one, but applications were using the old one. We checked external secrets. It had synced the new value into Kubernetes. The secret object was updated, but pods were still running with old variables. They had not restarted, so they never picked up the new password. Now we had a mismatch. Database expected new, apps were using old. At this point, Slack was escalating. Can we roll back the password? Can we restart all services? Is there a safer way? We had to act fast. The issue was not rotation itself. It was how rotation interacted with our runtime. We updated the database password successfully. External secrets synced the new password into Kubernetes, but our applications consumed secrets as environment variables, which are only read at startup. We had no mechanism to restart pods, so when the password rotated, the system split. Database moved forward, application stayed behind. And since the old password was immediately invalidated, there was no grace period. Every connection attempt failed. It was a perfect timing issue. Everything worked exactly as configured, but the system as a whole broke. First decision was how to restore access. Rolling back was risky. Instead, we decided to move everything forward. We triggered a rolling restart of all services that depended on the database. Started with critical ones. Auth, payments, user service. As pods restarted, they picked up the new password. Connection errors began to drop. Then we scaled the restart across the cluster. Within minutes, services started recovering. Error rates decreased. User-facing functionality returned. Full recovery took about 25 minutes. After that, we stabilized. Then we fixed the underlying issue. We introduced a mechanism to trigger restarts, using annotations and a reloader controller. We also updated the rotation process, added a short overlap window where both passwords were valid. What failed was coordination. We automated secret rotation, but we did not automate secret consumption. We assumed update was enough. Detection was reactive. We saw errors after the break, not during the rotation. We had no alert tied to secret changes impacting connections. Observability showed symptoms, but not the sequence. There was also a design assumption that credentials could be rotated instantly without impact. In reality, distributed systems need transition periods. Secret rotation must be paired with application reload strategies. Without that, rotation is a break. Environment variables are static. If you need dynamic secrets, use sidecars or volume mounts with live updates. Rotation should include a grace period. Old and new credentials should coexist temporarily. Critical infrastructure changes need end-to-end testing, not just isolated validation. And finally, automation without coordination creates hidden failure modes. In the end, nothing crashed, nothing scaled down. But a single password change was enough to stop the entire system.